Well, good afternoon, everyone, and welcome to Chapter 8, or Unit 8, I should say. We are officially in the last unit of the year. Woohoo! With 8 classes left, 7 classes left for my seniors. We're ready to roll. So, this is kind of an interesting unit. This is called the graphs of rational functions. I'm probably going to break these notes up into 2 different parts. The first part will be explaining how to graph a rational function, and the second part, I'll explain vertical asymptotes and horizontal asymptotes. So, if you're following along with me, here we go. So, our target is to be able to find an asymptote of a rational function. And the first thing you need to know is what is a rational function. So, a rational function is a function that's written as a fraction. So it is written as a fraction. So we're going to have a fraction, and we've never graphed anything like this. So usually it'll be something, it could have a 1 over an x, or it could be an x over like x squared plus 2, something like that. But a rational function means we're going to be graphing things that are written as fractions. That's our key. So the official definition, it's a function formed by dividing one polynomial by another polynomial. So we just call this r of x is equal to p of x over q of x. In other words, this r of x is going to be our y equals. So when we get ready to graph, and you can use your calculator in this, so go ahead and grab that if you need to. So the denominator is the bottom. So that is your q of x. And the thing about having this q of x at the bottom is, remember, when we're dealing with fractions, we can't have something that has a 0 at the bottom. So that means it is undefined if we have a 0 value at the bottom. So that's one of our restrictions. So one of the functions, this function, the bottom, cannot equal to 0 ever. So it can never equal to 0. Okay, it cannot. So of course, the values that make 0 in the denominator are going to be what are called our restricted values. So the domain, which, remember, those are our x values of a rational function, include the x for which the denominator does not equal 0. So it can be anything in the whole wide world besides the values that make it equal to 0. Now, we have seen this once before. So we did square roots and we did fractions. Actually, we did even roots, so not just square roots, but fourth roots. So before, we looked at anything that had like an x under a radical with an even root. We said that x had to be greater than or equal to whatever made that a 0, a positive 2. And then we had another one where if it were 1 over an x, let's say that, then x could not be equal to 0. If it were, then that would give me a restricted value in the domain, which is the denominator. So if it does that, so we can use the domain restrictions to help us what are called the vertical asymptotes. So now that we're looking at graphing these things, we need to be a little more specific about what they are. So not only are they restrictions in the domain, they have a purpose. They're called vertical asymptotes, which means they're going to be lines that the graph gets closer and closer to in the vertical direction. Okay, so a vertical asymptote will look like this. Vertical lines that your graph gets closer and closer to but can never touch. So how do you find out what the vertical asymptotes are when we look at equations? So in order to find out what vertical asymptotes are, I only look at the denominator. So I'm only looking here. Well, that didn't work out very well, did it? Let me erase that. So I am only, let me try it again. I am only looking at denominators. So those are the values that are going to tell me what the restrictions are in the denominator. Now we find them exactly the way that we did before. So if I have x minus 4 in the denominator of this particular rational function, then whatever value makes it 0, so I'm going to say x minus 4 is equal 0, whatever value of x makes it equal to 0, that is your restricted value, and so therefore it has a new name. It's called a vertical asymptote, and we're going to call vertical asymptotes just a VA, and it stands for vertical asymptote, but we don't want to write that every single time, so that's why we're stuck on VA. Now, some of you will be able to look at this and tell me right away that the value that makes x 0 is a positive 4. Some of them are a little more challenging, and so if you set your denominator equal to 0 and solve, you're going to find out that you can pretty quickly find out what your vertical asymptote is. As you scroll across these, you can see, like letter B, that one might be a little more challenging for me to find out what value of x is restricted in the denominator or the domain. So if you say x, my 2x minus 5 is equal to 0, the value that is restricted or that makes a 0 in the denominator is my vertical asymptote. So if I add 5 and I have 2x is equal to 5, and then I divide that by 2, x is equal to 5 halves. Well, if I put that value in here, that's the one that makes a 0. So therefore, that is where my vertical asymptote is found. My vertical asymptote is x is equal to 5 halves, or 2.5 if you want to give it to me in a decimal form. That's it. Now, I like this because you've done this once before. We have looked at vertical asymptotes before. We just didn't know what we were looking for. We called them restrictions in the domain. But when we get ready to graph these, you're going to see that they are going to be vertical lines. And I'll just go ahead and give you a quick picture of what it looks like. So one of them will be going at a 2.5. So 1, 2.5. There'll be a vertical line right in between there. And that's what's called a vertical asymptote, meaning your graph is going to get closer and closer to it. I'll give you a quick little picture about what it looks like also. Let's go with purple. Okay, so it's going to do something like this. So it's going to go closer and closer to it in both directions. So it's going to look like this. Okay, now we haven't seen many of those before. I don't know. Here we go. Let's see if it'll let me turn blue. There we go. That's what I was looking for. All right, so these are going to be the strangest little graphs. You've never seen anything quite like this before, but that's okay. Let's go on. So the second or the third one, letter C, if I'm looking for the values of x that are restricted in the denominator, this one might not be as easy for me to find. So if I say 0 is equal to 3x squared minus 6x, I see right away, because this is a second degree, that there are 2 restrictions in the denominator, meaning there are 2 values that x cannot be. Now, you have your choices as to how you solve it. You can factor it. You can use a quadratic formula. You can use algebra if it's possible. However you choose to find out what the values of x are that will create a 0 is totally up to you. What I'm going to do here is I'm probably going to factor it. So I'm going to take out a 3 and an x. And if I do that, then I'm left with an x minus a 2. Now remember, once we've factored both of these, you set both factors equal to 0. So 3x equals 0, x minus 2 equals 0. And if you divide this by 3, then one of your restricted values is 0 itself. And the other restricted value, when I add 2, is x is equal to positive 2. So I actually have 2 restricted values here. One was x equals 0, and the other x equals 2. So when I get ready to tell you what my vertical asymptotes are, my VA, there are 2 of them, x equals 0 and x equals positive 2. So those are the 2 restricted values. Now that graph would be something really weird. And then if you wanted to take a quick look at what it would look like, let's see if I can I should probably stop before I mess it up. We'll do that at the end. Oh, there it comes. All right, so if I pull up the calculator and I go to my y equals, and I put in, and now here's the key to this. I have to put this in with parentheses. So x, and then divided by, in parentheses at the bottom, a 3x squared, and then minus a 6x. Now watch how weird this looks. And I hate we're not here together so I can do this for you. You can see this, especially with this colored graphing calculator. I love it. There it is. So those are the two branches of this particular asymptote, and it has, or this particular graph, and it has two asymptotes in it. It's never going to touch 0, and it's never going to touch, in this case, a positive 2. So there are two vertical asymptotes. Anyway, that one's a little deceiving because it has a removable in it, but that's okay. All righty, last thing we want to look at before I do some examples for you, and then I'm going to cut the notes off for just a few minutes. So we have vertical asymptotes, and we are also going to have what are called horizontal asymptotes. Horizontal asymptotes, remember, are going to be lines moving in the horizontal position like this that your graph will never touch. So your graph is never going to touch. So just for the sake that we remember this, asymptotes are lines that the graph approaches but does not touch. Now, there are some exceptions to that. If you get to your calculus classes, you're going to find that there is an example. There is an occasion where a horizontal asymptote will jump over it, but it doesn't ever touch it. It just jumps over it. Now, there are three different things I have to analyze in order to tell you what kind of horizontal asymptotes I have. Now, there are three, but I'm going to start at the bottom with number 1. Now, we're going to have to know how to find the degree of a polynomial. Now, remember that your degree is your highest exponential value. Exponent value of a variable. So when I get ready to look at a degree, and I'm looking at a numerator versus the denominator. So if I'm getting ready to look, and I'll show you a little more about that in just a minute, the degree of the numerator, if it is greater than the degree in the denominator. For example, you have an equation that looks like this: x to the 4th over x to the 2nd. Do you see that your top degree is a 4 and your bottom degree is a 2? So if your degree in the numerator, or the top, is greater than the degree in the bottom, so a 4 and a 2, so the degree in the top is bigger than the degree in the bottom, then what that means is there is no horizontal asymptote. Now, guess what we're going to call horizontal asymptotes? HAs. So if the top degree is bigger than the bottom degree, there is no horizontal asymptote. Now, I'm going to back up one. What if the degree in the bottom, or the degree in the numerator, is less than the degree in the top? Okay, so let's say I have y equals, and this time I have x to the 2nd on top and x to the 4th on the bottom. So in other words, the bottom is greater than the top. And if you want to look at that, you can see I've got a 2 in the top and a 4 in the bottom. So the degree in the top is smaller than the degree in the bottom. I like to say it a little bit differently. I like to say the degree in the bottom is bigger than the degree at the top. And if that's the case, then your horizontal asymptote it is always y equals 0. Always. So a horizontal line is a y equal line. A vertical line is an x equals line. Now, those two are the easiest, I think. And here's the last one, number 3. If the degree in the numerator, which is the top, is equal to the degree in the denominator, which is the bottom. In other words, when you look at your equation, you see x equals 4x squared over 3x squared. And do you see that both of these are degree 2? So if that happens, something very interesting occurs with my asymptote. So if my top is equal to the bottom, now what I mean are your top degree is equal to your bottom degree. So that means the value of the exponent of your variable. If those two are equal, then what happens is your horizontal asymptote is equal to your top lead coefficient over your bottom lead coefficient. All right, and what I mean by this is this. All right, do you see that your lead coefficient in the top is 4 and your lead coefficient in the bottom is 3? So if the 2 degrees are exactly the same, then your HA is y equals whatever the lead coefficient is in the top over whatever your lead coefficient is in the bottom. Very cool stuff, but it is a lot to remember. So a lot of things you've got to practice, and without me there to see you and to give you a couple of things to work on with degrees of equations, it is going to be a little more challenging. So I'll try and give you some more stuff just to be able to find degrees. Now, these are all things that you have done throughout the year, but now we're finally at the end where we're putting everything together, and we're trying to now graph a rational equation. All right, so I'm going to stop here for just a minute, let you digest this, and then I'll come back with a second video to give you some examples. Okay? Have a great afternoon. You will have a worksheet on this, worksheet number 1 in Packet Unit 8. Let's see, there are 12 questions. Not a lot of work. You just have to understand what you're looking for. So I'll be looking for some class time with you guys, just so I can answer questions if you have any. Okay? So, be well, everyone. Take care. And I will talk to you hopefully, well, maybe one day. I'll see you all again really soon. Okay? Take care, everyone.